Okay, this is the fourth section of chapter 3. It's unit 6, polynomial functions. So it's hard to imagine how everything comes together in this unit because it does take a long time to go through. It's one of our longest units. This unit here talks about finding zeros of polynomial functions. So we're specifically looking for the x-intercepts. And we're going to use the rational zero theorem. It's also called the rational root theorem. And it's just a tool to help you determine all possible real and rational zeros for a polynomial function. So there's actually a lot going on. It's saying possible. It doesn't say that it's going to find them. Real means they actually physically cross or touch the x-axis. A non-real example would be like 3i. So this isn't going to help you find the non-real. And rational zeros. This is going to help you find the rational zeros, like 3 is a rational number. 2/3 is a rational number. -5/4. Those are rational. An irrational number would be like the square root of 3. So this is only good to find possible, real, and rational zeros. And some books do this a little bit differently. Most of my students don't remember this until I refer to the letters that are typically used. We're going to look at a polynomial, and we're going to look at the factors of the constant term. Some books refer to that as P, and the factors of the leading coefficients. Some books refer to that as Q. So a lot of my students remember this as P over Q. They don't remember anything else. So when we look at this, P are the factors of 16. So to get 16, I could have 1 multiplied by 16, or I could get -1 multiplied by -16. So I'm going to say plus or minus 1. And I like to keep these in order, so I'm going to put 16 at the end since it's the biggest number. I could have 2 and 8. So plus or minus 2 and plus or minus 8. I could have 4. 4 times 4. So now I'm just going to build this up to, like I said before, it was 8 and 1 and 16. Then I would look at the factors of the leading coefficient. So 16 is the constant. The leading coefficient, in this case it's really easy, it's 1. So the only factors of 1 are plus or minus 1. So the possible zeros are going to be 1 over 1, 2 over 1, 4 over 1, 8 over 1, and 16 over 1. So that's all I'm looking for in these first example, is to identify the possible zeros. But that term possibles is very important because this is a quartic polynomial. This is a degree of 4. So the most I can have in zeros is 4. Well, this lists 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This lists 10 of them. So I know there's no way all of them are used, and it may be not any of them are used. So the next example, I'm going to do the same thing. I always do the first example where the leading coefficient is 1, just to give you an idea, but it's not a very good example to understand it. So the first thing I'm going to do is this next example, it's all in mixed up order. So it's not as easy to find the constant and the leading coefficient. So I'm going to go and rewrite this in order. So this is going to be negative 6x cubed plus 3x squared plus x plus 10. So my constant is 10. So the factors of 10 are going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. 1 times 10, -1 times -10. 2 times 5, -2 multiplied by -5. And then my leading coefficient is going to be 6, well, -6. But it doesn't matter if it's positive or negative. So I could have a positive 1 times a -6. I could have a -1 times a positive 6. I could have a positive 2 times a negative 3. I could have a negative 2 times a positive 3. So those are my numbers. Now this is going to get ridiculous, and I apologize. I choose this example just to show you how this works. So my possible zeros. I'm going to have 1 over 1, 2 over 1, 5 over 1, 10 over 1. Now I've got 1 over 2, 2 over 2. Well, 2 over 2 is 1, so I'm not going to write it again. 5 over 2, 10 over 2. Oh, wait, 10 over 2 is 5. I don't need to write that again. Now I have to put everything over 3. So 1 over 3, 2 over 3, 5 over 3, and 10 over 3. I'm running out of room. I'm going to come down here. Now I have to do everything over 6. So 1 over 6, 2 over 6. Well, 2 over 6 reduces to 1/3. I've already got that. I'm not going to worry about doing it again. So 2 over 6, 5 over 6. I need that one. And then 10 over 6. 10 over 6 reduces to 5 over 3, so I'm not going to write that again. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Told you it was going to be ridiculous. But those are the possible zeros. So math, there's a lot of shortcuts for things. This is a long drawn-out process. We don't typically use it, but it's something that's in the curriculum because you're expected to see it. After this unit test, you probably won't use it again in this course. Okay, we're going to use this rational zero theorem to solve polynomial equations. So the specific steps is we're going to make sure that we list all possible real rational zeros. So let's look at this one. Well, this is going to be easy. I've got the leading coefficient is 1 and the constant is 10. So my possibles are going to be plus or minus 1 and 10, plus or minus 2 and 5. So there's my possible zeros. These are just possible. Well, now I've got to figure out which zeros work. And to do that, I'm going to use synthetic division. Synthetic division is a lot quicker than long division, and it doesn't matter to me where I start. I'm just going to start with a smaller number because it's easier. So in using synthetic division, the positive 1 goes here. I put my leading coefficients for each term. And I go ahead and I do this, and I'm going to do it fairly quickly. Bring down the 1, multiply, add, multiply, add, multiply, and add. Okay, so I know 1 doesn't work because I don't have a remainder of 0. Remember, the factor theorem says for a divisor to be a factor, the remainder has to equal 0. So this one's no good. So I'm going to try another number. Let's try negative 1 because it's an easy number. So 1, negative 2, negative 13, and negative 10. Bring down the 1, multiply, add, multiply, add, multiply, add. Okay, good. There it is. I have a remainder of 0, so I know that this x, this one here, x plus 1 is a factor. And just like before, this quotient is going to be x squared minus 3x minus 10. And this, if I multiply this together, I get back to this. So I want it to equal 0. And I want to solve this equation. Well, this is a quadratic. We've been solving quadratics for a long time. This particular problem, I made it so it can be factored. So I'm going to go ahead and factor. So this will factor into x minus 5, x plus 2 equals 0. So I get set each factor equal to 0. And my solutions are going to be x equals negative 1, 5, and negative 2. This is a cubic equation. Those 3 zeros, they're all real and they're all rational. And I can check this in a calculator. So I've got my equation is x cubed minus 2x squared minus 13x minus 10. And there it is. There's negative 2 is here, negative 1 is here, and 5 is wherever. I can change the window a little bit. Let's go to the right a little bit. Negative 2, negative 1, and 5. I can look at the table. If I look at the table, let's start at 0, go increments of 1. So negative 2, y is 0, negative 1, y is 0, and 5 is 0. So that is also a way to check it. And I know there's probably some of you out there saying, well, why, if you can use a calculator, do I have to do this? Remember, this is just a tool. This is just a technique. This is a skill. If you were to have access to a calculator and you were trying to solve a polynomial equation, by all means, pick up a calculator. I'm just testing you on a skill that I teach you. But now you can use that information. So I've got 2 more problems, and each one gets a little bit longer. So this next one, I've got 2x cubed plus 11x squared equals 3 minus 10x. So the first thing I have to do is rearrange this in descending order. So this is going to give me 2x cubed plus 11x squared plus 10x minus 3 equals 0. I have to list my possible zeros. So my factors of negative 3 are plus or minus 1 and plus or minus 3. That's my constant. My leading coefficient is 2. So my factors of that are plus or minus 1, plus or minus 2. So my possible zeros, once again I'm emphasizing possible, 1 over 1, 1 over 1, 3 over 1. And then I have 1 over 2 and 3 over 2. Now, to save us time, and usually I would have, the first day I'd have students go through this and do the synthetic division and try to discover how to find it. And then the second day I would say, okay, let's use a calculator. So we're going to just go ahead and go right to the calculator. So I'm going to type in this equation. Let's see, 2x cubed minus plus 11x squared plus 10x and minus 3. And I always double check it. 2x cubed plus 11x squared plus 10x minus 3. And I'm just going to go ahead and graph it. I know it's a cubic, and this is why we do that other section of this chapter first. So I knew what it was going to look like. I knew it was going to have this shape here. And it's crossing the x-axis in 3 places. Well, I need to figure out if one of those 3 places is one that I can use. So I'm going to find a 0, and negative 1, negative 2, negative 3, negative 4. So this one looks like it's between negative 5 and negative 4. So negative 5 is on the left, negative 4 is on the right. And I get, oh, negative 4.236. I don't think that's, I know that's not one of these numbers here. So I'm going to try the next one. The next one is between negative 2 and negative 1. So 0, I'm going to look negative 2, negative 1. Oh, negative 1.5. Okay, well, negative 1.5 is good. That's the same thing as saying negative 1.5. Negative 1.5 is negative 3/2. So that's the 0 I'm going to use. So negative 3/2 goes here. I have 2, 11, 10, negative 3. Bring down the 2. 2 multiplied by negative 3, negative 6 over 2, gives me negative 3. Add these, I get 8. 8 times negative 3 over 2 will be negative 24 over 2, which gives me negative 12. When I add these, I get negative 2. Negative 2 multiplied by negative 3/2 will be positive 6 over 2, which gives me a positive 3. It gives me a 0. That makes me happy. That's what I want to see. Remember, if I didn't get a 0 here, I either picked the wrong value to put here, or I've done my math incorrectly. So that means I've got x plus 3/2, 2x squared plus 8x minus 2 equals 0. So what happens is I can actually factor out a 2 from this. This 0 I know is negative 3/2, but this one here, I can factor out a 2. And I'd rather do that because I'm looking at that and now I see it from here. There's no way I can factor that. So I'm going to go ahead and use quadratic formula. So I get x is equal to negative b squared minus 4 times a times c all over 2 times a. This 2 doesn't make a difference. If I'd have put that in here, my numbers just would have been bigger. So I get negative 4 plus or minus, see, 16 plus 4 is 20 over 2. I guess I didn't need to go that long. So I get negative 4 plus or minus 2 square roots of 5 over 2. This will reduce. Everything's divisible by 2. Negative 4, 2, and 2 are all divisible by 2. So my solutions are going to be negative 3/2 and negative 2 plus or minus the square root of 5. And I can go back to here. And let's find, it doesn't matter. Let's look at this third one here. It's between 0 and 1. So left bound is 0, right bound is 1. When it says guess, I hit enter, I get 0.236. So negative 2 plus the square root of 5, 0.236. So that verified it. So yes, you can use a calculator. It would give you the decimal approximations. The other one being negative 4.236. But this gives you the exact value. Okay. And also double check yourself, because this was a cubic, it's going to have 3 zeros. So negative 3/2, negative 2 plus the square root of 5, and negative 2 minus the square root of 5. Last example is I've got a quartic now. So this one's got a little bit more going on. And usually when I create the test for this unit, I don't put a quartic on it because it just takes more time. And if you could do a cubic, you could do a quartic. But I'm going to sign a couple out of the book, so I want you to see it. So my leading coefficient and my constant. So first I look at my constant is negative 28. So plus or minus 1, 2, 4, 7, 14, and 28. 3 is my leading coefficient, so I'd have plus or minus 1, plus or minus 3. So my possible zeros: 1 over 1, 2 over 1, 4 over 1, 7 over 1, 14 over 1, 28 over 1. Then I have 1 over 3, 2 over 3, 4 over 3, 7 over 3, 14 over 3, 28 over 3. Those are just my possible zeros. Now I'm going to go ahead and graph this function because I don't want to sit there and try all these numbers. So I'm going to go to y equals and type in 3x to the 4th plus 11x cubed plus 17x squared, oops, plus 77x minus 28. Double check everything. Negative 28 plus 77 minus plus 17 plus 11. Okay, so now I go to the graph. Okay, I only see 2 spots where it crosses the x-axis. I'm going to zoom out and look at it, see if it's any different. Now I truly only see 2 spots, and that's okay. I'm not worried. I want to find what those spots are. So this first one here looks like it's -4. If I do second trace, 0. So -4 is between -5 and -3. Yep, I was right, -4. So I'm going to put a -4 out front. 3, 11, 17, 77, -28. Bring down the 3, multiply, add, multiply, add, multiply, add. Nope, not. Yeah, -84. I knew I made a mistake somewhere. -84, because I knew this problem had worked. Now when I add them, it's -7. -7 multiplied by -4 is a +28. So there's 0. So that means I have x plus 4, 3x cubed minus x squared plus 21x minus 7. Well, this is a cubic, but don't forget, when we did this, I found 2 of them already. I used that first one, so let's use the second one. So second trace, 0. It looks like it's between 0 and 1. So I'm going to do left bound. Instead of saying 0, let's go -1, just to be sure. And the right bound, instead of saying 1, I'm going to go to 2. And it's okay, I can go a little bit bigger. And when it says guess, I hit enter. Okay, so 0.333333 repeated. That I recognize as 1/3. So now I'm going to use 1/3. But I'm going to use it on this cubic that's here. So I have a 3, -1, 21, -7. Bring down the 3, multiply. 3 times 1/3, 1. Add them, I get 0. That's okay. Makes it easier, actually. 0 multiplied by 1/3 is 0. Bring down the 21. 21 multiplied by 1/3 is 7. Add those, I get 0. Remember, I have to have a 0 there. So this gives me x plus 4, x minus 1/3, 3x squared plus 21. Well, I know this gives me -4. This gives me 1/3. I saw those in the graph. This 3x squared plus 21 equals 0. So 3x squared equals -21. X squared equals -7. So x is going to equal plus or minus I square root of 7. So that's what happens. I couldn't see it in the graph because it's not a real number. And I cannot find it. It's not going to be in this list of numbers because these are only the real numbers. Tedious process. Stay with me. Don't get frustrated on this. Go slow. I don't give a lot of problems in this section. Just get through it, and then in the future, if you have a teacher that says, you remember the rational root theorem, and you're going to say no, and they go, do you remember the p's and the q's? You're going to say, oh yeah, I remember those. That's all I really ask for.